Okay, let me see. Now, if you look, hey, listen. So, before I start the next topic, is there anything that you need to see from page 8 or 10? No? Okay. Yeah, which one? Which page? 10. 2B. Okay. Anything else? Yeah, okay. So if you look at page 10, please, 2B. Okay, so we've got this point here, -3, -6. Okay, and 4x plus 9 equals 0. So this one's a little bit difficult because it's not clear. But if I rewrite it like this, now maybe it's a little bit clearer because we don't have any y's. So the y part is actually 0 here. So you get a equals -4, b equals 0, c equals 9. So I think that's the complication there with that one. So the distance would be -4 by -3 plus -6 by 0 plus 9 all over square root 16 plus 0. So that would be 3, is it?
Yeah.
As the answer. Yeah? No.
No.
Did I do something wrong? Oh, the 9. I forgot about the 9. Sorry. So that would be 12 plus 9, so 21 over 4.
Yes.
Yeah, so is that 5.25?
Yes.
Is that okay? Is it okay?
Yes.
Yeah? You sure? Yeah? Yeah.
Kugelschreiber. So also, what I'll do now for some people
Number 6 on page 8, and but I think you just missed me doing an example of one from page 10. So I'll do, maybe you can copy the notes from someone, but I'll do number 6 from page 8 now. Okay, so if you look at number 6. So in number 6, A, both. I'll do A and B, yeah.
But you did A on the lesson.
Did we do A in the class?
Yeah, you did. Yeah, yes, you did.
Okay. Are you sure? I did 6A in class.
What?
I did 6A in class.
Oh no. Yes, 6.
No, I think I did 8A on the previous
you
one.
Explain why the answer should be like.
Alright, well I'll do it again anyways. Okay. Listen now, listen. So I'm going to, it doesn't matter if I did it, I'm doing it again. 6 from page 8. So you have the line L intersects the y-axis at 2. So there's the line L. And it's parallel to the line K, or I don't actually call it K, which is y equals 3x plus 1. So I know the slope of this line must be 3. So I have y equals 3x plus c. Now I also know a point on this line. It's the point 0, 2. So I can put that point in and I get 2 equals 0 plus c. So c equals 2.
You just add in the 2 from the beginning.
You could if you wanted to, yeah. I'm just making it clear, but that's fine if you did it like that, yeah. Okay, now the next one's a little bit trickier. So, for the next one, the B part, the line K intersects the x-axis at 3. So there's K, yeah, and now it's perpendicular to this line. I'll just draw it up here. And this is the line K, this is the line L, I guess. I gave it a different letter. And this one is y equals minus x plus 1. But I actually want the equation for this line. So the slope of this line on the top is minus 1. So what's the slope of the line I want? 1. So I get y equals 1x plus c. Now what's the point on this line? It's 3, 0. Yeah. So I have 0 equals 3 plus c. So c equals minus 3. And then we get y equals x minus 3. Yeah. So that's the answer for that one. Yeah. Okay, so write that one down as well if you need to, and then we'll go on to page 12. Okay. Yep, you have this. Okay, so page 12 now. Listen now. So, if I draw two lines on the same graph, will they always meet or not?
No.
No, when will they not meet?
When they're parallel.
When they're parallel. So, with the exception of parallel lines, two lines should always meet somewhere. Okay? So, for example, here is one line, minus 6 plus 8. And here is the second line, minus 7x plus 9. And we would like to know, where do they meet? What's the word that describes where they meet?
Point of intersection.
Intersection, yeah. Point of intersection, intersection. We want to know where they meet. So I want to know what the intersection point is. And today we'll learn 4 different ways to find it. In the exam, there are 4 different ways they could ask you to find it. 3 of them from this page, and 1 of them from a different lesson, okay? So I'm going to show you 4 methods today, but you only need 3 of them for the exam, to know 3 from the exam, for the exam, okay? So the first one, okay. So first method is by using the graph. So method 1 would be to use the graph. So that is, we have to draw each of these. Now we spent some time this week learning how to draw these graphs. So I'll draw this one first. Oops. If x is 0, what's y for this graph? If x is 0, y is 8. And then we'll try and do it in our head. If y is 0, what's x? 8 over 6, which is 4 over 3.
For the first graph.
Just for the first one, line, yeah. Now for the second line, if x is 0, what's y? 9. And then if y is 0, what's x? Yeah, 9 over 7. So, let's try our best to draw this. This is 1a, by the way. Okay, so we'll try and draw the neatest graph I can. Oh, that's already terrible. I need to go to 10. All right. Zoom in. Do that one again. Okay, what was the first point?
0 over 8.
Okay. And what was the second point?
4 over 3, 0.
So, are the y's x small, y big, x small, y big, x small, y big, x small, y big? Okay, so in this graph here, each of these boxes will represent 1 unit. But it'll be way too small if I do 1 unit on the x. So I think I'll go, yeah, maybe make 5 boxes equal to 1. So 1, 2, 3, 4, 5. I can even do more, but 5 will be easy. 1, 2, 3, 4, 5. Okay. So there's 1. 1, 2, 3, 4, 5. There's 2. 1, 2, 3, 4, 5. There's 3. And this is 1, 2, 3. Okay. Sorry, the first one was 0, 8. There it is there. And what's the next point? What's next? 4 over 3. So that would be around about here. And 0. Okay. So that's 4 over 3 and 0. All right, that's the first line. Now, what's the second, or the next point for the next line?
0,
9. So that would be here. And then it's other point?
9 over 7, 0.
9 over 7, 7, 1 and 2, 9. So that would be...
They're almost the same.
Yes, this is why I think I even needed to make this graph bigger. Sorry, what did I say? Can you give me that as a decimal? 9, what's it? 9 over 7?
1.28.
1.28, and this one is 1.33, so it'll be a little bit less than it. And okay, 9 over 7 and 0. Sorry, I know it's hard to see. And I'll draw the second line. Somewhere here, I'm going to go with 1.3 as the answer. No, not close enough. 1.2. Now look, when you get graph questions in the exam, they will let you be, a little bit inaccurate. You can be off a little bit. So my answer is 1.3, but when I look at the back, the actual answer is 1.2. I know it's not great, but it's not too bad. It is the worst one. So whenever you have a choice, you don't use this one. But sometimes you don't have a choice. Sometimes the question will say, use method whatever. Yeah, well, in the exam, you'll get graph paper that will be as big as this page. So, if I did this on graph paper that's this big, I'd get probably the right answer. But I'm using it on this, and for me, the screen only looks like it's this big. In the exam, it'll be easier for you, okay? So, if you had a choice, you don't do it this way. So let me show you what a nice graph looks like. So first one is y equals minus 6x plus 8. And then the second one is y equals minus 7x plus 9. So that one. And then this one here. Now you see, you can't quite see it. That's because this x-axis is too big. So I need to make it smaller. There we go. And the y-axis is not big enough. So I need to make it bigger. Not great, but not too bad. Where's zoom in? Okay. Yeah, so that's not very clear, but it's not too bad. You can see you go up to 1 and across to 2. So you can see that this point here, yeah, it is roughly 1, 2. It's not too bad to see. Okay? So you can have graph paper in the exam to help you do this, if it is in the exam. Okay? So that's the first method. That's using the graph. Okay, so now on to the next method. So the second method, I think it's a method some people would know. Yeah, substitution. Y equals 3x minus 9. And y equals 2x plus 5. You know what, I'll just change this one a tiny bit just to make it a bit more difficult so it doesn't look so easy. 2x minus y plus 5 equals 0 as an example. So the idea with the substitution method is for the first equation, you know that y equals 3x minus 9. And even if you didn't, even if I wrote it like this, 3x minus y minus 9 equals 0, you can see it's not difficult to rearrange it into this. So once you have y here, you then replace it in the second one. It's a replacement. So this now becomes 2x minus y, which is 3x minus 9, plus 5 equals 0. And you'll notice that you only have x here. You don't have any y. So now this is like the first lesson. 2x minus 3x plus 9 plus 5 equals 0. So this will be x equals 9 when you work it out. How do we get y? Not a problem. We just take this answer and put it back in here. And we'll get y equals 18. 27 minus 9. And that's the answer. Isn't it? No.
It's
No,
14. It's 14. X equals 14, not 9.
Yes, that it's not the 9,
No,
sorry.
that's the 5.
I forgot the 5 again. Forgetting the number at the end today. Right, so x is 14.
Yeah.
So let's recalculate that. 42 minus 9. 33. Okay, there we go, that's the answer. And that is right. Yeah.
Where did you get the y equals 3?
Where did I get which one?
The y.
Oh, this one here? I take the x equals 14 and I go back to the start and replace the x now. Replace the x with 14. So I get y equals 3 times 14 minus 9. That's 33. Yeah? Is it okay?
Does it have to be like, do you have to substitute from the original or? Like
No. Any equation that's in the question. Yeah. That was the easiest one to use though. Yeah. Okay, so that's the substitution method. So what is the substitution method? Pretty much you take one equation and you put it inside the other equation. That's the substitution method. Okay, I'll just give you a minute to write that down. I should also say you can write your answer like that, although it's a little bit better if you actually give it like this, 1433.
Right, that's the final.
Okay, can I go down to the next method? Yep. Okay. The next method is the most common and it's the one probably all learned at high school or middle school. So this method here, elimination method. So this is method 3. Let's write down the example here. 3x plus 4y equals 5 and 2x plus 5y equals 1. Okay. So I'm sure everybody has seen this because it's the method that everybody really uses at school. So what you do is you try and make the x's here the same. So that means you should multiply this by 2 and this one by 3. Because if you multiply this by 2, you'll get a 6x. And if you multiply this by 3, you'll get a 6x. So if I do that, I'll get 6x plus 8y equals 10. And 6x plus 15y equals 3. Then what happens next is you're allowed to plus or minus. And what I choose to do here is minus. The reason I choose minus is to cancel these. 6x minus 6x, well that's gone. 8y minus 15y, that's minus 7y. 10 minus 3, that's 7. So therefore, y will equal minus 1. But we still must find the x. So likewise, what we do is we take this here and we'll put it back into one of these. I'll put it into the second one. Looks a little easier. So we have 2 times x plus 5 times minus 1 equals 1. So that means that'll be 3 for x, I think. Yeah. So the answer is 3 minus 1. So far, I'm going to show you another one. And then there's still one more method to show you. So I really have 5 in total, but only 4 for the exam. Hey, focus now. Did you write that down?
That's good.
Sit quietly. Try not to distract me. Okay. You got that? Yep. Okay, so the last method now for this worksheet. So it's still actually an elimination method, but it's a very special type. Gaussian elimination. Some people find this method useful, and it works pretty well when you have more complicated problems. And I'll show you how to use this method with this example 4a. So 2 over 7 x minus 3 over 5 y equals minus 5 over 9. 2 over 9x minus 1 over 2y equals 5 over 7. Now, if you use the graph method, your answer will be very inaccurate. If you use substitution, it'll be very messy because you have to rearrange and then sub it in. You have lots of fractions. If you use the elimination method, that's not too bad. But before you use the elimination method, you'll have to remove the denominators here. But Gaussian elimination works well when you have a messy one like this. Okay, so what we do, to save time, we don't write it like this all the time. We write it shorthand. So we write 2 over 7 minus 3 over 5 minus 5 over 9, dot, 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 dot. 2 over 9 minus 1 over 2, and then 5 over 7. And when I write this, it means the same thing as this. It's a type of shorthand, so you don't have to write x, y, and equals each time. Okay. So write that down so far. Yep. Okay, so if I scroll down a bit. Okay. So the first thing I do is I will get rid of the fractions. So if I wanted to get rid of all the fractions here, what number would I need to multiply it by? Well, 7, 5, and 9, right? I need to use all 3. And then what about here? What would I have to use? 2, 7, and 9, if I wanted to, okay? But the way the Gaussian elimination works is you don't have to cancel all the fractions. You just need to cancel this fraction here. So if I want to get rid of this fraction, what would I have to multiply it by? 7. Yeah. If I just wanted to make the number 1, what would I multiply it by? 7 over 2. So if I multiply this by 7 over 2, it becomes 1, isn't it? Now what would I need to multiply this by to make this one 1? 9 over 2. So you'll need your calculator. That's what we'll do first. So, oh, and by the way, sorry, I'll make that minus here because I want to make this minus 1. So in this process, the first step is to make a 1 and a minus 1. That's the first step. So I know that this will be 1 and minus 1. Okay, can someone multiply this for me, please? Minus 3 over 5 times 7 over 2. What's that, minus 21 over 10? Yeah, okay. And then this one here would be minus 35 over 18. Yes, okay. This one here is minus 1. This one here will be 9 over 4. And then this one here will be minus 45 over 14. Is that okay? Yeah? So, first thing you need to know is you're allowed to multiply any line by any number except 0. Okay? So, I choose these two numbers here. That's your first rule. You're allowed to multiply any line by any number. Okay? There's only two rules. First one is any line multiply any number. And the second rule is you can add any line into any other line. So I will add this line into this one. One minus 21 over 10 minus 35 over 18. So 1, and if I add it to minus 1, 0. Now please, you need the calculator here for sure. So add these two together. Minus 21 over 10 plus 9 over 4. What do you get? Calculator, come on, someone tell me. Add these two. What is it? 3 over 20. Good. And then add these two.
Negative 325 over 63.
Negative
325
325
over 63.
over 63. Okay. And now the very last thing to do is I want to multiply again, and this time I want to make this number here 1 again. So this is fine. I can keep this the same. What should I multiply here? 20 over 3. So if you still have this answer on your calculator, can you multiply it by 20 over 3?
Negative 6,500 over
6,500 over
189.
189, 0 and 1.
Why is it that do we leave this at 1? Why does it leave it at
3 over 20?
Yeah.
Ah, you will see why now. So, if you think about it, I can rewrite this back using x and y. So, to make it clear, what exactly does this mean? It means x minus 21 over 10 y equals minus 35 over 18. And 0x, y, 1y, you see, equals minus 6,500 over 189. So you see, when it's in this form, I have the y. And when I have the y, I can get the x. Now, in the exam, you don't need to write that down. I only wrote it down to explain what's happening here. But once you get it in this form, you can see the y is equal to this.
Yeah.
Yeah?
You go up.
Yes. To the previous one here, is it?
Yeah.
Yeah? Okay. All right, write that down, so. Okay, so we could stop there because we know the y. What's the y? Minus 6,500 over 189. But let's say we want to be really fancy. Let's say we want to try and get rid of this number as well. So, anybody have any ideas how I might make this 0? This number here, how can I make this 0? Using my two rules of multiplying and adding.
You can times it by, you just use both. Multiply by minus 10 over 21
Yeah.
and then add 1 to another.
If I multiply this by 10 over 21 and then leave the negative and then add together, So multiply it by 10 over 21. So can you do that, please? So in fact, if you wanted to save time in the exam, you could have done those two multiplications in the same step. Okay? So we'll just pretend we did that. But I need to remove this. Can I remove this? Yep. Okay. Well, I suppose I just need to remove the first line. Okay, so can you multiply the first one? And what do you get? That would be 10 over 21. That would be minus 1. And then when you multiply this one by this one, what do you get?
25 over 27.
Okay, just a sec, sorry. What do you say, negative? 25 over 27. Yeah, when that multiplies that, it makes this one. I would have thought it looked bigger. All right. Somebody said what to do next. What should I do next? Add which line? The second line to the first. So then we get 10 over 21, 0. Okay, so somebody needs to add these two together for me, please. So if you add these two together, what do you get? Come on, this one plus this one. Someone type it in, please.
Negative 2,225 over 63.
Okay. And to finish, if I want to make this 1, what should I multiply by? 21 over 10. And here, 1. So I get 1, 0, 0, 1 minus 6,500 over 189. And then finally, this multiply 21 over 10.
Negative 445 over 6.
So, what does x equal? There it is there. What does y equal? That's it there. So this is Gaussian elimination. You try to end up with this situation at the end. You have 1 and zeros, 0 and 1.
So I must have 1, 0.
No, you don't. No, you don't need to. Remember earlier I said we could stop when we got the y. That's fine.
Yeah.
I'm just going to do extra steps just to show you the idea of what you can do.
So that's why I can stop it then.
Yeah. Once you have y, you can stop there. Yeah. Yes? Yeah, that's the next method we'll do. It's similar, but not quite the same as this. Oh, the matrix method is simpler. Yeah. Yeah, pretty much, yeah. So you have x equals answer, y equals answer, yeah.
Oh, this is C.
What's wrong? Okay, listen, hey. Just to clear up something here. Can I go to the side here? As a minimum, what you need to finish with at the end is a number, 0, a number, ... a number, whoops, and a number. And the reason for that is because this one, what does this give you?
Y.
This gives you y, and then you can substitute it back here and you can get the x. Okay? But if you want, you can go further, like I did, and you can try and get it like this. 1, 0, 0, 1, number and number. And if you manage to get to this step, you can clearly see this is x and this is y. The reason I like this method is because it works really well when you have many unknowns. Like let's say x, y, z. If you had x, y, z, what you would need to do is get a number, 0, number, and number, 0, 0, number, and a number.
The last one should be 1, not number.
It's okay if it's a number, but yeah, I suppose it'd be a bit nicer if you could get it as exactly 1. It doesn't really have to be 1. It's just nicer.
You could turn it into a 1.
You could easily turn it into a 1, yeah. So if this was x, y, z, what does this line here give you?
Z.
Gives you z. Because this will be no x, no y. 1z equals the answer there. Now what is on this line? What letters?
Y and Z.
Y and z. Do you know z?
Yeah.
You do, so then you can find y. And what's on the first line? X, y, and z. Do you know y? Yes. And z? Yes. So you can find x. So the secret to this method is you must at least get a corner of zeros. So if you look back at my example here, I could have stopped here because I had a corner of zeros. I had a 0 in the corner. Like here, I have 0 here. And again, if you had more, W, X, Y, Z, number, 0, X, Y, Z, number, 0, 0, Y, Z, number, 0, 0, 0, number, number. Like that, if you had more. So that's why I like this method, because it's easier to make it more complicated. Hey, look. Look. In this method here, this one here, this is just the original question written out in this form. So this is one step, and then this is the second step. And then if you want to make it into 1, you can. So that's the third step. And then once you're here, you're done. Because you know y equals this number. And then when you have y, you have x. So what I like about this method is you can always do it in 3 steps. You can always do it in 3 steps. So each question will take at least this many steps. And it always has the same process. First, you make a 1 and a -1. Secondly, you add them together to make a 1 and a 0. And then finally, you multiply to make this a 1. And you're done. Okay, so it's a clear procedure. It's a clear process. And that's part of the reason of why I'm showing you this method. So you have a clear structure always to solve these. This method is not on the exam though. Okay, so in the exam, they will only ask you use graph, use elimination, or use substitution. But if they don't ask you, then you can choose any method you want except the graph, because the graph is not accurate. Okay? Alright, so which ones do I want you to try now? So if you mark these, please. Eraser.
Which do we? Which first?
Okay.
I'm going to give you a choice.
I'll slap it in class. Right, listen. So the ones I want you to do from number 1. Yeah, from 1, 2, and 3, C, D, and E. 1, 2, and 3. Okay, so 1, C, D, E, and 2, C, D, E, and 3, C, D, E. So that's 9 questions, and I'll give you one more. In number 4, just do B. Okay, so that's 10 questions. Okay, so do that for 10 minutes, then we'll take a break for a few minutes and start the next lesson. Whatever you don't finish, that's what you do at home.